Hello everyone. Hope you guys are doing well. Miss getting to have you in class. So last week we had three lessons, 11:4, 11:5, and 11:6. Hopefully you guys felt pretty good about that. From those of you who have turned them in so far, things are looking pretty good for the most part. It seems like everybody's understanding it pretty well. Hopefully for those of you who haven't submitted it yet, you're still feeling pretty confident about it, and hopefully by the time you see this video you will have it submitted, is my hope. We are continuing on, so like I said, we finished up last week with 11:7 or 11:6, so what we're going to be looking at this week is 11:7, so more with our multiplication still. So this is multiplication as scaling. So what scaling means is when we're thinking about taking something that's really, really small and making it bigger, or vice versa, taking something big and shrinking it down. We can use factors to help us scale that to either make it grow or make it shrink. So in this case, it just depends on the problem whether we're making it grow or shrink, but it's what's known as scaling. So we're going to be looking at a lot of comparing in this. So I know there's a lot of words on this, but just bear with me. So how can multiplying by a fraction change the second factor? Sue knitted 4 scarves 4 feet long for her and her friends, Joe, Alan, and June. After a month, they compared the lengths of their scarves. Some scarves had stretched and some had shrunk. The results are in the chart. So Sue, her scarf was 4 feet still, so hers didn't change. Joe's, his was 1 1/2 times 4. Alan's was 3/4 times 4. And June's was 3/3 times 4. So, how had the lengths of the scarves changed? So what we're looking at here is seeing, did they get bigger or did they get smaller? And how we'll do that is through multiplication. So obviously we know Sue's stayed the same. Hers didn't change, it's still the 4. We didn't multiply by any factor. But Joe, Alan, and June, theirs all changed a little bit. Now, we're going to do June's first just because hers is the easiest once you really look at it. So we have this 3/3. What do we know 3/3 represents? 1 whole. You got it. So this right here is the same as 1 times 4. And 1 times 4 is just 4. So did hers change at all? No, it didn't. So Sue's and June's stayed the same. So Sue and June. So they were the same. Now we need to look at Joe and Alan. So on Alan's, we're taking 3/4 times 4. So we're taking a fraction times a whole number. So remember, we do 3/4 times 4/1. 3 times 4 is 12. 4 times 1 is 4. Now we have 12/4. Can we reduce that? Yes, we sure can. So we're going to. So 12 divided by 4 is 3. So what happened to Alan's scarf? His shrunk. It went from being 4 feet to now it's only 3 feet. So Alan's shrunk. Now we need to look at Joe's. So we're taking a mixed number times a whole number. So we've looked at this just in our last lesson that you guys did. So the first thing we need to do is convert it to an improper fraction. Yes, so 2 times 1 is 2, and 2 plus 1 is 3. So this is really 3 halves times 4. So now we have a fraction times a whole number. So same thing that we did for Alan, we're going to do 3/2 times 4/1. 3 times 4 is 12 again, yes. And 2 times 1 is 2. Now, can we simplify 12/2? We sure can. So 12 divided by 2 is 6. You got it. So what do we notice about Joe's scarf? Did it shrink or did it get bigger? It got bigger. It got a whole 2 feet bigger. So Joe's stretched. Now, what you guys are going to be taking and looking at, part of your assignment will be to take and determine whether or not in this case, whether or not the scarf would have shrunk or gotten bigger without having to multiply. So how we can tell this is by what we're multiplying by. If we're multiplying by a number less than 1, so 3/4 is less than 1, so if we multiply by anything less than 1, it's going to make it smaller. If we multiply by anything bigger than 1, it's going to make it bigger. So, number greater than 1, bigger, number less than 1, small. So that's a key thing right there when we're taking and doing these. So if you've got a fraction less than 1, now be careful, make sure it is less than 1, then that's going to be the case. It's going to take and get smaller. But if you have a number more than 1, now our 3/2, that's still a fraction, but 3/2 is more than 1. 2/2 would be 1 whole. 3/2 is more than 1. So keep that in mind on that first section of your worksheet for this lesson, okay? All right, so we're going to look at some more examples of this to give you guys lots of practice as always. So, like I said, part of your assignment will be to take and compare. So our first problem over here, we have 3 1/2 times 2 2/3, and we want to take and compare whatever this is to our 2/3. So we're going to multiply 3 1/2 times 2 2/3. So 3 1/2, 3 times 2 is 6, plus 1 is 7. So we've got 7/2 times, convert our 2/3. 3 times 2 is 6, plus 2 is 8. So we've got 8/3. Multiply this, so 7 times 8, 7 times 8 is 56, over 2 times 3 is 6. So now we need to take and determine, is that larger than 2 2/3? Well, how many times can 6 go into 56? 9 times, you are correct. 6 times 9 is 54. And 56 minus 54 gives us 2 6, which would be 9 1/3. So 9 1/3 is what to 2 2/3? Bigger or smaller? Well, it's bigger, so we're going to use our greater than symbol. All right, so hopefully that makes sense. You got to take and multiply this through and determine. Now, thinking back to what I just said on that last one, if we have a number that's greater than 1 and we're multiplying it, it should make it bigger. But I want to see, so on the first half of the assignment, you just have to take and determine based on the numbers whether or not it's greater or smaller. Then the second section, you're taking and multiplying it just like what we did here, to prove that it really is greater or less than. Okay? So you're going to have greater or less than on your assignment, and I believe in the directions it says use greater than, less than, or equal to, because there could be some equal to's in there, to show the relationship between the values. All right, so our next problem, we have another 2 2/3, so we know 2 2/3 is 8/3, so I'm just going to write that down right off the bat, since we already have that math done for us. And now we have 4/5. So we have 4/5 times 8/3. 4 times 8 is 32. Excellent. And 5 times 3 is 15. Wonderful. All right, so how many times can 15 go into 32? Twice. Excellent. So we have 2. So 15 times 2 is 30. 32 minus 30 is 2. So we've got 2 and 2/15. Now, Which is bigger, 2 and 2/15 or 2 and 2/3? 2 and 2/3, you are correct. So another way that we could have gotten that answer is looking what we're multiplying by, our scaling factor. Keyword there is scaling. So remember, on Canvas, there is that assignment listed. So go to your assignments on our Canvas page, and you will see an assignment that says 11-7, video keyword, and you're going to type in scaling, and then you'll get points for that. So make sure you do it. If you do not do it, you will be losing points. So make sure you do this. So referring back to this, remember, if it's a number less than 1, it's going to make it less than the original value. If it's a number greater than 1, it's going to make it greater than the original value. Hopefully that is making sense to you guys. All right. Another comparing problem. So we've got 4 3/5 times 4/4. Now notice, I switched where our regular number is and where our scaling number is. Remember, with multiplication, it doesn't matter what order you multiply things in. You're going to get the same answer either way. 3 times 5 equals 15. 5 times 3 also equals 15. It doesn't change it to switch the numbers around. So it's a property known as commutative that tells us that we can switch numbers around when multiplying and we'll still end up with the exact same thing. So with this, it doesn't matter if the scaling number comes first or if it comes second. Also remember, scaling is your key word for this lesson. All right, so looking at this, we have 4 3/5 times 4/4. What do we know 4/4 is? 1, exactly. So really this problem is 4 3/5 times 1. What's 4 3/5 times 1? 4 3/5, you got it. Oops. So what's our comparison? 4 3/5 is what to 4 3/5? Equal to. So like I said, you might have some equal to problems on here. The only time that you should end up with an equal to is when you have the whole number of 1 that you're multiplying by. So if you have 4/4, 10/10, 24/24, any of those, they will all reduce down to 1. So anytime your fraction reduces down to just 1, then you know that the two numbers are going to be equal because your scale factor is just 1. So it just means it's the exact same size. Okay? All right, couple more problems to take a look at. Okay, so why does multiplying a number by 3.5 increase its value? Well, what do we think? Why does it increase its value? Because 3.5 is greater than 1 whole, so it makes the given number larger, just like regular multiplication. If we were given a problem saying 5 times 3, that's going to be 15. 15 is a lot bigger than 3, right? We're just throwing in that half, which, yes, will adjust what our answer is. It's going to affect it, but it's not going to make it decrease. Because we have that full 3 there, it's going to make it increase. All right. And our last question. So, does the scaling factor always have to be the first factor? No, it does not. Looks like my always got a little erased. Sorry. No. 1/4 times 3. Oh, excuse me. 1/4 times 3 and 3 times 1/4 are the same problem, where 1/4 is the scaling factor. So like I was saying, multiplication is commutative, which means it doesn't matter what order you multiply in. It's going to get you the same answer either way. So the scaling factor does not necessarily have to be the first factor. Note, scaling is underlined. Scaling is your key word to submit on Canvas. So make sure you guys are taking and doing that. It is worth points, like I said before. So some of you have been turning in assignments but not taking and doing those videos, or not doing the video keywords. So make sure you are doing that. It is part of your grade. If you don't do it, you're going to lose those points. So make sure you're doing that. Like I had said last time, the Canvas, our Canvas page, specifically 5th grade math, looking under it, looking at that announcements tab, and also at assignments is going to be the two places that you need to look at the most throughout this time. So announcements, it's going to have the list of what the assignments are. It's going to have the links to the videos. It will have the PDFs. Remember, those PDFs, they are in very fine print down at the bottom. It's kind of frustrating, but when I attach them to the announcement, it does a little link down at the very, very bottom. So right under where I say Miss Nofsker, it's going to have that link for the PDF. But it will only let me attach one PDF per announcement. I'll put the second PDF in the reply, so I will reply right back to my announcement. In that, it will have the other PDF. I'm also this time going to take and send out the PDFs to your guys' email, because I know a lot of you are struggling to find those PDFs. So to make life a little easier, I will have them in multiple places in the hopes that then you will all have access to them and all be able to get your work done. If you have questions, make sure you're contacting me. A lot of you have been, which has been great. If you're stuck on things, that's awesome. Office hours are from 1 to 2, Monday, Wednesday, Friday. Also, if you get stuck, Miss Capron will be available to help you, or if she doesn't know for sure what you need, or if it's a specific question for me, she can relay that to me to find out what that answer is for you guys, okay? But make sure you're doing your work. This is getting graded. All of these assignments are. And the keyword. So make sure you're checking for that. Okay, guys? All right. Have a great night. I hope you guys have success with this lesson. And hopefully this week goes a little bit smoother. All right. Bye.